Is the slide visible? You'll have to answer me back because I cannot see your chat. I cannot see your messages.
Yes, ma'am, it's
Okay.
visible.
So we have completed the unit 2, and now we are going to start with unit 3. So this is the syllabus of unit 3. In unit 2, we have studied about the automated production lines. Likewise, we have automated assembly lines also. But before we understand what are automated assembly lines, we will first know what are these manual assembly lines. So in unit 3, we'll first be studying the manual assembly system. In that, we'll be studying the fundamentals of manual assembly lines, then the analysis of single model assembly line. In that, we are studying repositioning losses, line balancing problem, line balancing algorithms. In this line balancing algorithms, we have these different methods. One is the largest candidate rule, Kilbridge and Wester method, rank position weights method, and simple problems covering all the three methods. Okay, so you have problems in manual assembly lines. In automated assembly lines, you don't have any problems to solve here. So in automated assembly systems, we are studying the fundamentals of automated assembly systems. In that, we are studying system configuration, part delivery at workstation. These are the elements of the part delivery actually, the hooper, part feeder, selector, feed track, escapements and placement devices, their applications, and we'll be studying what is partial automation. So in unit 3, the first half part, that is the manual assembly systems, will have problems, and these problems are going to be it's like you have these tables, you have the precedence diagrams and all. So it's kind of a procedure, and every method that you see here, the largest candidate rule, Kilbridge and Wester method, rank position weight method, is they are all going to be on the same lines, but yes, with some difference, of course. So the problems are quite interesting here, and are very important. In automated assembly lines, we don't have any problems. The automated assembly line, I cannot say this is half of the unit, maybe some 30-35% of this unit. Major part is the manual assembly systems here. So to start with, we'll start with what is this manual assembly line. Okay, so everybody, I hope, understands what do we mean by an assembly operation. We have known what are these production operations, where actually some task is performed on the part in order to convert it from a raw material to a finished product. Okay, so after all those operations have been performed, all those different elements are going to be then assembled in order to make a final end product, right? So assembly basically is just going to be a process of building up all of those elements in order to make one final product. So here again you have options of either having a manual assembly line or it can be an automated assembly line. So what do we mean by assembly line? It is nothing different from the production lines. It's just a set of workstations which will be arranged in a sequence, and at every workstation there is some task, specific task that will be performed in order to complete the product from its initial stage to the final stage. Okay, so so what is this manual assembly line, or yeah? So basically, most manufactured consumer products that we see, or the products that we are using, they're almost all are assembled products. So each product, what happens, they consist of multiple components, which are going to be joined by various assembly processes. Okay, and these kinds of products are usually made on an assembly line. So we have number of products that you have been using. These are these consumer based products. Some of the products to be listed are, you can just think of your furniture at home. Even if you consider a simple chair, it is an assembled product, right? If you consider any type of chair, may it not be a wooden chair only. So different elements are then going to be joined in order to make a end product. Likewise, we have refrigerators, pumps. If you can, automobile is the best example for an assembled product. You have these um, computers, they are also assembled, microwave ovens, washing machines. Then you have the toasters, telephones, stoves. There's so many products that you see around are all assembled. Okay, so there are certain factors which will be favoring the use of manual assembly line, which are shown on the slide here. So the factors that favor the use of manual assembly line. That is, when do we go for these manual assembly lines instead of automated assembly lines, right? So whenever you have a high or a medium demand of a product, you go for these manual assembly lines. Also, when the parts are identical or they are similar. Next is when the total work content, it can be divided into work elements. Of course, you will go for a manual assembly line. You'll be putting an assembly line only when the work that has to be performed on it can be split into um, minor works. Like the total work content has to be divided into a minor or small work elements. Only then you can put this into an assembly line, right? If everything has to be done only at one station, then there is no point in having an assembly line where you have number of workstations arranged in a sequence, right? So it is one more factor is when it is technologically impossible or and sorry, economically infeasible to automate the assembly operations. So yes, we come across such operations which may be economically infeasible to have an automated assembly line. In that case, we will think of having some human interventions and human interference, and you go for a manual assembly line. So these are these factors. Okay, these are these four factors considered whenever it comes to manual assembly lines. So most consumer products are assembled on the manual assembly lines. Okay, so all the products which are characterized by these factors that we have just listed, they are usually made on a manual assembly line. And also, there are several reasons why manual assembly lines are so productive when you compare it to the alternate method in which multiple workers each performs all the tasks to assemble the products. So, why assembly lines are so productive? Okay. One is because of these certain principles that are taken into consideration. First is this specialization of labor, that is division of labor. Okay, which is nothing but the learning curve, where that is a large job. It is divided into smaller tasks, and each worker becomes a specialist in performing that single task. So we know the importance. If one person is made to do everything with respect to that particular part, he may take more time and he may not be a master in performing all the tasks that are required. Instead, if we divide the work in between a number of workers, and every worker is made to do one specific task, I'm very sure that he or she is going to be a master in performing that task, and he or she can perform it at a very faster rate. So here, specialization of labor, which is also called as division of labor, this principle basically it asserts that when a large job is divided into smaller tasks and each task is assigned to one worker, the worker becomes highly proficient at performing the single task. So each worker becomes a specialist in performing that particular task. Therefore, the productivity will be increased when you consider this principle of division of labor or specialization of labor. Next principle is interchangeable parts, that is components, they are made to close tolerances. Of course, when it comes to assembly lines, if this particular principle is not applied, then there cannot be assembly lines itself. Okay, so interchangeable parts is a very important thing to be considered here, because what happens is interchangeable parts in which each component it is manufactured to sufficiently close tolerance that any part of a certain type can be selected for an assembly within its mating components. So you pick any of the parts and you can use them to be mated with some other component, irrespective of checking their dimensions again and again. If you're producing them to a very close tolerance, they can be mated to any of their components. So without interchangeable parts, assembly would require filing and fitting of mating components, rendering the assembly line method impractical. Right. So if this close tolerance was not considered or not given to all the components, then every time you pick any part, it had to be filed, and again you have to bring it to the dimensions such that it can be mated to its other components. So close tolerance is very important. Um, and that is one of the major principles that have to be taken care here. Otherwise, it will be very difficult or it will be impractical to have these assembly lines. Next, third principle is the workflow principle. That is, the products are brought to the workers. That is, traveling the minimum distance between stations. So, workflow principle, it involves moving the work to the workers rather than vice versa. Instead of bringing or instead of the workers coming to the work table to work, you rather move the work to the worker. Each work unit it is going to flow smoothly through the production line, traveling minimum distance between stations. So as I said, in assembly line also you will have a number of workstations which will be arranged in a certain sequence. So if you have one worker standing in front of one workstation, and if the work parts are moving from one station to the other station with the help of maybe some manual work transfer or some mechanized or some automated work transfer, the work will be carried out at a faster rate than the worker moving to the work. Right. Next is line pacing. The worker must complete their task within the cycle time of the line. So workers on an assembly line are usually required to complete their assigned task on each work unit within a certain cycle time, which paces the line to maintain a specified production rate. So pacing here generally is implemented by means of a mechanized conveyor. So line pacing becomes very important, and if if you are taking more time than the cycle time, then of course the productivity or the production rate is going to get hampered. Okay, so line pacing principle is one of yet another important principles to be considered. And overall, if all of these principles are implemented properly, then you can see that these assembly lines are going to be way much productive. Okay. So here, initially, as I said, we are discussing only about the manual assembly lines, and in the later part, we'll be studying about the automated assembly lines. So manual assembly lines means what? You have human beings, you have workers who are involved in the assembly process. Whereas in automated assembly lines, you will see that the workers are not majorly involved in all the assembly activities. Okay. But manual assembly lines become very important because there are some of these tasks that have to be performed, right? When it comes to assembly tasks, they include all these welding operations. It may be some stamping, stitching, maybe some press fitting. There can be some adhesives that have to be applied. There can be some brazing, mm, yeah, riveting and all of these processes are a part of these assembly operations, so it does require workers to be there in order to perform all these tasks. Okay, so these are typical products made on assembly line. I've already listed these, like their furniture, cooking ranges, automobiles, microwave, washing machine, toaster, telephones, refrigerators, and so on. So these are the parts, and you have many, many more parts which are actually assembled. You can think of one part which is not assembled. You can just, if anybody has one part in mind which is not assembled, then you can just let me know. But otherwise, every damn thing that you see around, every product that we are using is assembled. The number of elements that go in the assembly may vary. Some have a large number of elements getting assembled in order to make the final product. Some may be having a very less number of parts. If you even consider a water bottle has its own body, plus there's a top on it, right? So even that is kind of an only with that top it becomes a complete water bottle, which is going to serve the purpose of storing the water in it. Okay, had the top of it not been there, then the water would have got completely spilled off. So even if you consider the simplest mobile phone that we are having, there are so many elements that go in to make that one complete mobile phone. Though it looks a very compact device for us, but when you open it up, there are so many number of elements that are there which are assembled to make the final product. So coming to the fundamentals of these manual assembly lines, so we'll first define what is this manual assembly line. So it's a production line which is consisting of a sequence of workstations where assembly tasks are performed by human workers as the product moves along the line. Okay, am I audible to all?
Yes, ma'am, you're audible.
Okay. So this is the basic definition of an manual assembly line. That is a production line which is consisting of a sequence of workstations where assembly tasks are performed by human workers as the product moves along the line. So please understand the difference between production line and an assembly line. Of course, the complete arrangement may look very similar in both the cases, but here you are going to have these assembly tasks performed, whereas in the production lines you have the production operations performed. Okay, so here so the products here are assembled as they move along the line. Okay. So at each station, a worker performs a portion of the total work on the unit. Here, the common practice is to launch the base part. You can see it here in this figure. This is the manual assembly line figure which is shown here. And this is like a line configuration, a simple line configuration with n manually operated workstations. So every blue color box that you see, these are the assembly manual. When we say ASBY, it is the short form for assembly, and MAN means manual assembly. If instead of MAN here it was AUT, that is automation, then it could have been an automated assembly workstation, right? So here what happens basically, the parts, the base part, it gets launched at the entry at one point, and then it starts moving from one station to other station, and then it comes out as a completed part. So at every assembly station that you have some other components added to it in order to complete it. So you start with launching the base part, to which all the other components, whatever are required, are going to be. For example, suppose if there is some adhesive to be applied, then you have the adhesive coming in from here, and that adhesive will be applied to that launched part, that is the base part, and then it will move to the next station. Then maybe some welding operation has to be performed. So here is a station where welding will be done. That operation is performed here. Then it is moved to the next station. Like that, you have the sequence followed, and which results in an assembled product at the end. So here what happens is the common practice here is to launch the base part onto the beginning of the line at regular intervals. Each base part then travels through the successive stations, and the worker adds the components that progressively build the part. A mechanized material transport system is typically used to move the base part along the line as they are gradually transferred into final product. So what you see here is the work part transport system, which will be mechanized. So you have the worker standing in position, and the work part, it just comes in front of them. They have to perform the task, and back on this work part transport station, it moves to the next station. Sometimes the worker has to perform the task as the work part is moving along. It will be moving at a constant speed. I hope you all have seen these different videos of a car getting assembled. So you see there are so many robotic work part transport systems in place. They will be moving the parts from one station, or maybe you can just imagine a a powered conveyor, which is carrying a huge work part. As it is moving from one station to other, you will see that the workers, they themselves will be moving along with that part and quickly assembling or doing any of the tasks that has to be performed. So even that is possible here. So a mechanized material transport system is typically used to move the base part along the line as they are gradually transformed into final products. So the production rate of an assembly line is determined by its slowest station. So we know it is the bottleneck station which will be deciding the production rate. So even if there is any of the station which is going to perform the task very fast, at that station, suppose if the work is getting performed very fast, it's of no use, because the production rate is going to be dependent on the bottleneck station itself, the station which takes the maximum time to complete any task. So the complete production rate will depend on that bottleneck station. Okay, so these things are over. So the manual assembly line technology, it has been made significant contributions to the development of American industries in the 20th century. Okay, so it is one of the very important production systems throughout the world in the manufacture of automobiles, consumer appliances, and other assembled products. So before we proceed to what are these to the next topic, that is what are these assembly workstations, I will quickly just brief you all about the history or the origin of these manual assembly lines. Okay, so these manual assembly lines, they were basically they are basically based on two basic fundamentals or principles. Okay, the work principles. We have already gone through those principles. I'll just tell you all how the origin, when it all actually started. So the first principle here is division of labor. Okay, and the second principle here is the interchangeable parts. So it all started there. Okay, so it was Adam Smith. Okay, this person in 1776, he published a book. Okay, and in that he is mentioned about this, how why this division of labor is important, and he's explained the whole thing with an actual case study. So what had happened is there was a spin factory, and that pin factory, he implemented this division of labor. Okay, not him, but the division of labor was implemented there, and he saw that there were these 10 workers. They were all specialized in a different task in order to complete or to manufacture one single pin. Whatever tasks have to be performed, every worker was specialized in one certain task. And it was observed that the group of those 10 workers, they could produce 48,000 pins per day, because each one was specialized in one task, one type of task, which helped in getting the pin made ready. They could, with their specialization in those tasks, they could get 48,000 pins made per day, compared to a system in which each worker was performing all the tasks in order to get a pin. So one case where all the people, all the, suppose one worker was completely involved in getting one pin made by performing all the tasks that have to be performed on it. The number of parts that they made was way less than the the pins made by the workers who were specialized in a certain task in order to make that pin. So this particularly proved that division of labor is very important when it comes to all these assembly lines. So Smith basically, he did not invent the division of labor. Okay, but he was the first one to understand the significance of this in the production. And the second principle, as I said, is the interchangeable parts. Um, so it is believed that without interchangeable parts, the assembly line technology would not have been possible. So interchangeable parts, manufacturing the parts to a very close tolerance is very important, or else the production rate and the complete assembly operation would have not been practically possible. Also, we have Mr. Henry Ford. He also had used this division of labor principle and saw that there was a lot of success that he could achieve. So, because of this, what happened? He also used these chain-driven conveyors and workstations that was all arranged according to their convenience and comfort in the assembly line. And the workers, their productivity basically increased a lot, and as a result, there was a dramatic reduction in the price of the parts made, because of course the production rate was increased, the productivity of the laborers had increased. Okay, and that's the reason whatever models they had made, specifically the Model T of Ford, that had shown a significant reduction in the price. And that time that particular model was in trend, and people used to go for that particular model. So the masses of America, they could afford an automobile because of Ford's achievement in cost reduction. And likewise, there were so many other competitors of Fords which had to again get into all these techniques of coming up with these automated assembly lines, coming up with these powered material transport systems, and applying all these principles in their uh, shop floors or in their workstations, in their factories, so that they could match up to the mark that was set by Ford. Okay, so moving on to what is this assembly workstation. Now we have just seen the fundamentals about manual assembly line. Okay, now I said in manual assembly line you have workstations, right? All these workstations arranged in a sequence will make this manual assembly line. So what is this assembly workstation? So it is said to be a designated location along the workflow path at which one or more elements are performed or one or more tasks are performed by one or more workers. Okay, so every location or a station where one or more workers are going to perform some task in order to complete the part or assemble the part. So what are these typical works or the tasks that will be performed at every station? It's listed here. Maybe there is adhesive application, sealant application, arc welding, spot welding, press fitting, some electrical connections to be made, soldering, stitching, thread fastening. So many type of tasks will be there based on what product you are assembling. All the tasks that are involved, they will be sequenced properly along the line, and the products are then going to be moved from one station to another where the tasks are going to be performed. So these so a workstation on a manual assembly line, it is designated location along the workflow path at which one or more work elements are performed by one or more workers. So the work element, it basically represents a very small portion of total work that must be accomplished in order to assemble the product. So typical assembly operation performed at that station, on that particular manual station, there are these operations which are listed here, which you can see on the slide. So given workstation, it also includes the tools which are required to perform the task assigned to the station. So in order to accomplish all these tasks, there have to be these tools which should be there on in place on those particular stations. So some workstations are designed for workers to stand, while others allow the worker to even sit and perform the task. So there are so many videos that you can just see if you are watching all these knowledge-based TV channels which are there. You will come across all of these type of assembly stations. There are these production stations. Of course, the names are different. The typical series which come there may be different, but what learning you can have from them are not different from what you're studying here. Okay, so whenever you're seeing some food factory series or some videos, some episodes, it's all about all these assembled assembly or automated production lines. They're all the same. So whatever you are trying to understand and learn from the courses, the engineering courses, the same application, the actual application part you can see when you see all these episodes on the channel. Okay, so basically. These workstations that we are talking about, these assembly workstations, it can either allow the worker to sit at a place and perform the task, or maybe the worker has to stand and perform the task. So when the worker has to stand, they can move around the station area to perform their assigned task. So example could be and automobile sector, wherein you have the automobile to be assembled from scratch. There you can see these people have been moving along the different parts of the automobile. They walk along with the part when the part is moving at a certain pace, at a certain velocity. With the help of these power conveyors, you can see the workers moving along with them. So they are either allowed to stand and work, or wherein they can be permitted to move in the station area to perform their assigned task. This is common for assembly of large products such as cars, trucks, or some major appliances. So the product is typically moved by a conveyor at a very constant velocity through the station. The worker begins to assemble tasks near the upstream side of the station and moves along with the work unit until the task is completed. and then the worker will start walking back to his square one position, where again there is a new part coming in, and again he has to repeat the task. And then if there are some smaller assembled products, like maybe some electronic devices, some other small appliances, the workstations are usually designed to allow the worker to sit while they perform the task. Now, suppose if I take an example of a mobile itself, if there is this mobile assembly that has to be done, you need not require the worker to move along with the sub assemblies. You can just sit at a place and do the task, and then it is carried forward to the downstream station. So this is more comfortable, the sitting position, and it is less fatiguing for the worker, and it is generally more helpful to get precision and accuracy in that particular assembly task. So instead of the accuracy and precision that you can see um, given by the worker when they are moving along the part that has to be assembled, the sitting position will give you a better accuracy and precision. Next is this work part transport system. Basically, this has two major categories, manual and mechanized. So both these methods provide the fixed routing that is characteristic of a production line. That means what the work parts that are transferred, they can either be transferred manually or they can be mechanized transport. That is either a human being, a worker can move the part from one station to another, or you have these mechanized power work part or transport systems in place which will be moving them on their own. So this part we have actually come across in automated production lines also. We have seen these synchronous or synchronous continuous transport. It's the same thing that we'll be studying here also. So you have these manual work. So we are first studying the first category here, that is the manual work transport system. So the work units here are moved between stations by the workers without the aid of a powered conveyors. So we do not have any mechanized, any powered conveyors that are used here. It is purely the worker who will be moving it from one station to another. So here types are the work units are moved either in batches or they'll be moved one at a time. But then yes, we face the problem of starving of stations or blocking, and there is no pacing that is maintained. So we have already understood what is starving and blocking. I will just repeat it again. So, in this manual method of work transport, the units of the products that are passed from one station to another, they are going to be done by the workers themselves. So, basically, as I said, there are these two problems of starving of station or blocking of station. What is starving? It is a situation in which the assembly operator has completed the task of assembling on the current work unit, but the next unit has not yet arrived at the station. So one person, the worker has completed his task of assembly, but and he's also sent it to the downstream station, but he's not getting any new work unit entering in or coming in for the task to be performed. So the worker is the starved of work. So, and what about this blocking of station? When a station is blocked, it means that the operator has completed the assigned task on the current work unit, but he cannot pass it to the unit in the downstream station because that worker is not ready to receive it. Okay, so the operator is therefore going to be blocked with work units. He cannot move it to the downstream, the next workstation. So, in order to mitigate all these effects, or in order to mitigate these problems of starving and blocking, what do? We are going to incorporate a buffer storage. So, a storage buffer, they will be sometimes used in between these stations. So, in some cases, the work units which are made at each station are collected in batches, and then they will be moved to the next station. So, in other cases, work units are moved individually along a flat table or non-powered conveyors. So when the task is finished at each station, the worker simply pushes the units forward to the downstream, that is to the next station. So space is often allowed for one or more work units in front of each workstation. This provides the available space of work for the station as well as room for completed units from the upstream station. So there is place in order to accommodate work parts coming from the upstream station. So hence the starving and blocking can be minimized here, which is one of the major problems. So, but one problem here is if you're including the storage buffers, the trouble with this method is of operation that it will basically result in a significant work in progress. Sorry, work in process. Okay, that is WIP. When it comes to work in process, the company will always aim at reducing the work in process. But because of all these issues of salving and blocking and incorporating a storage buffer, we are basically increasing the work in process. Okay, so which basically is economically undesirable. So also the workers are unplaced in lines and they rely on the manual transport method. The production rates are going to go low because everything is happening manual here. Though that's what happens, the production rate is going to get affected because there are these so many workers involved. There are so many reasons for the workers to not perform efficiently. This all is going to result into lowering the production rates. So this will be the last part of our discussion, that is mechanized work transport system, and we have already had a discussion with respect to this. That is, work units are moved by powered conveyors or other mechanized apparatus. So these powered conveyors or any other type of mechanized material handling equipments, they are used in order to move the units along the manual assembly line. So these systems can be designed to provide, basically, you can design them either to provide a paced or an unpaced operation on the line. So you can set the pace at which the part has to be moved, or it could be unpaced in an unpaced manner. Okay. So three major categories of work transport system that we have already come across here is continuous transport, synchronous or synchronous transport. So as we have already known what is continuous, synchronous and asynchronous, and we have also seen the graphs with respect to this, I'm not going to repeat the mechanized work part transport systems here. So these are some of the examples for continuous transport. You have overhead trolleys, the material handling equipments for mechanized work transport. You can see for continuous, we use belt conveyors. Then maybe there's overhead trolley conveyors. If you want to go for synchronous, yes, walking beam mechanism is the best example that we have known. Synchronous transport, it is power and free conveyors, cart on track conveyors, yes, automated guided vehicles. These all are the examples of asynchronous transport. So we will stop here. Line pacing I'll take in the next class. Okay, did you understand the basics of an manual assembly line?
Yes, ma'am. When will you share this PDF?
The third unit?
Yes, ma'am. Uh, is it according to the syllabus copy, so it will be helpful for us to revise and study for IA?
Yeah. This we are following the syllabus copy only. All what I'm
Okay, ma'am.
discussing now, it all comes under the fundamentals of manual assembly lines.
Okay,
I
ma'am.
think this is just the 10% of the syllabus I have discussed today. So I will take another week at least to give you the notes with respect to unit 3. Okay. So
Yes,
we will
ma'am.
do the first unit. And I think yes, internal is still late. It's not immediately now.
Yes, ma'am.
Um, yeah, so I'll do that. I'll share it, no problem. These are just the slides that we have, and then you can refer to the textbook for the other things. But when it comes to the problems with respect to these units, the unit 3, no, the things are going to be a little complicated with respect to how we are going to teach you, because it involves all these tables and all those things. So let's see how we can work it out. But anyways, whatever material is required, that will be shared.
Yes, ma'am. That is why I had asked about the notes, because I saw the syllabus copy.
Hmm.
Third, fourth, fifth unit are a little bit complex with the procedures.
Yeah. Third unit basically is fourth and fifth is still okay. Third unit little. Don't worry, we'll work it
Okay,
out,
ma'am.
no problem. We'll try and make it as easy as possible for you all. Or else then the handwritten solved problems, those things will be anyway shared only with you all. Okay, then we'll stop here.
Yes, ma'am.